I'm feeling a little nervous. This is my second engage talk, if I'm not wrong. But this time, lots of sporting vibes in the hall. I'm not a very sporty person. I don't think I can run for 100 meters. Uh, but I am invited to talk about artificial intelligence. So, artificial intelligence. If you guys are following me on YouTube, you know I'm crazy about artificial intelligence. I have talked a lot about artificial intelligence and its latest development. So, I'll give you a quick sneak peek of early stage of artificial intelligence. So when we are solving a problem, using our brain, let's say we can see all the possibilities. What we are basically doing is we are brute forcing all the possibilities. Like let's say we have a problem, we have five different solutions, then we are weighing the pros and cons of each, then we pick one. That is what we call brute forcing, and that's how early artificial intelligence machine works. So this is a computer called Deep Blue. This computer was built way back in 1990s. This computer was very specifically designed to brute force the entire probability domain in chess game, which we can do because a chess game is not that complicated. We can actually count the number of possibilities. So this guy is Gary Kasparov. Back in the days, he was the chess champion. So this computer could brute force the entire possibility domain in a chess game, and before you start playing the chess game, you know the checkmate moves. So you can actually follow that path and beat the human. As human beings, we can't do that. We cannot brute force that huge probability domain. So this guy lost the game to a computer. So that was a historic moment in artificial intelligence, that a man got defeated by a machine. But we have a little problem here. This is not how human brain work, because we never brute force all the possibilities all the time. As Gaia, you said, we follow gut feelings, intuition, and that kind of stuff. So we call it the emotional compass. So after this point, lots of people were thinking, can't we teach the same thing to a computer? Can we? Emotional compass machines can actually like have feelings, and they follow feelings and that kind of stuff. So in these days, if you guys are huge fan of Star Trek, so early AI actually worked like this guy Spock. But then again, we figure out that we can't work like Spock all the time. So personally, I am a person who's looking into all the logical possibilities and weigh pros and cons. But at a certain point in my life, I came to this profound realization that I can't do it all the time because I'm wasting lots of my brain power, conscious brain power. But same thought came to computer scientists as well. So they were thinking that we can't do this. We can't brute force everything. Instead, we have to use a soft approach. We have to collect all the possible information, not all the information, all the possible information, and use some kind of approximation. We can't be precise 100% all the time, and sometimes we have to take risks, so we have to teach machines to take risks, and trying to be good enough. We cannot be 100% precise, but we have to be good enough. So how to teach this kind of complex stuff to a computer? We cannot use traditional approach. We cannot use traditional computer algorithms. Like if you guys are writing code, you know, we have sequence, selections, and iteration. We cannot use that kind of stuff. Or we need a newer approach, like this guy. Again, if you are watching Tech Track, you know who this guy is, Kirk. So this guy is always taking risk, use approximation, follow gut feelings. But eventually, he lives. He lived, right? At a certain point, he died because he followed the gut feeling. But yes, this guy got lots of things done with the gut feeling, human intuition, emotional compass. So we are trying to make our artificial intelligent machine more like this guy and less like Spock. So then they are getting closer to us. So how to do it? To do that, we need very specific hardware and software configuration. We call that artificial neural network. And then we need machine learning. The machine learning means when you build the artificial neural network, it's a blank slate, it's a blank paper, it does not know anything. But you can teach things to this artificial neural network. So we use machine learning. We have three main approaches: supervised, unsupervised, and reinforcement learning. We'll talk about those stuff later. So it's like this. this kid is trying to walk. If I ask you guys to document the process of walking, it's going to be a one hell of a nightmare. Like how to explain, like how to document this walking process. You have to balance yourself in your left leg, and you can't do that. But how this baby is learning to walk. So this tiny human is looking at the grown-up humans and thinking, okay, these grown-up humans are doing this thing called walking. Uh, can I do the same thing? I'm just crawling. I can't do that. So this guy is looking at these grown-up humans, and this tiny human is trying to look at this and just trying to mimic that thing. So if we can teach a computer to do the same thing, maybe we can show a computer, okay, this is how we walk, can you do the same? And this is how my friend walk, can you learn something from that? So we can show lots of samples to computers. So that's what we call machine learning. So we are slowly training this computer's artificial neural network to learn something. By doing this, we cannot be 100% precise, as I said. It's using a soft approach. It's trying to be good enough. That's exactly what we do too. So that's the story of machine learning, and this is a classic example. This is a computer built by famous company IBM. So they have built this machine based on some kind of artificial neural network, and it's a general purpose artificial intelligent machine. That means you can train this machine to do practically anything. So they were thinking like, okay, this machine can learn things which we cannot define logically. Can we teach this machine to do art, something we cannot define, but we can do? We can show it to you, and we can go to school and learn art, but we cannot really define it. So they were thinking like, what if we ask IBM Watson to edit a movie trailer? Editing a movie is a complex task, but editing a movie trailer is in the next level. You cannot give away the story. You have to keep the curiosity. So what this guy did was, it's a machine. It can go to internet and watch all the movie trailers, which we cannot do. It will take decades for us to do it. But this guy went online, watched all the movie trailers, and get some help from human teachers. And after some time, this guy got this idea, and what does it mean by a movie trailer? And it edited a movie trailer of this movie. You can go to YouTube and search for it. That movie trailer was edited by a non-human entity, which is unbelievable, but yes, it's true. So machine can do art. Machine can be creative. To do that, again, we have to use this soft approach, and we are taking risks. We are trying to be good enough. And the next thing, human intuition. So human intuition is some kind of processing we are doing as human being in the subconscious level. We have our conscious brain and the subconscious brain. In the subconscious brain, lots of processing going on which we cannot control. It never stops. Even when you're sleeping, your subconscious brain is actually working. So subconscious brain is working beyond your control, but those results are surfacing as emotions. Whenever you feel good, you just go ahead and do it. Whenever you feel bad, you quit it. So that's what we call the emotional compass. So can we teach this to a computer? What do you guys think? So whenever we have these good emotions, we sometimes logically it doesn't make any sense. But you just go ahead and do it because you feel good. And sometimes it's a really good logical choice. All the numbers are adding up, but you feel bad. So you are just dropping it. So we have that capability, and most of the time experiences says that they are actually correct decisions. Life experience. So what do you guys think? Can a machine do that? Okay, what do you think? Very unlikely, right? But computer scientists, so I am into computers, so I am into this subject. At a certain point, some computer scientists, they tried it. So to try this, to test this thing, we need a scenario where we need a game, not like chess. In chess, we can try out all the possibilities. We need a game where we have to use human intuition. So fortunately, there's such a game, and that game is this. It's an ancient Chinese board game called Go. So it looks like a very simple game, but when you look into the configuration of this game, various different configurations. So if you count all the configurations of this game, that's exceeding the entire number of atoms in this whole universe. So if you are trying to brute force it, it's out of the question. So you can't brute force it. And if you ask the world's best Go player, why did you make that move at that point? So probably that guy will say, I felt good. You cannot logically explain it. And why didn't you take that move? So probably that guy will say, I felt bad. So if a computer can play this game, that means the computer also should feel good and feel bad. So this company from England called DeepMind, it's a Google company, they created this artificial neural network called AlphaGo. This computer was, it's a general purpose computer. It can train to do anything. They train AlphaGo to play Go game. So how did they do that? We cannot define it. So if you cannot define it, you have to show lots of samples to this computer. They show thousands and thousands of Go games played by humans to AlphaGo. It took maybe several years. Then this computer slowly understand what does it mean by playing a Go game. Then they invited the world's best Go player, Dialog, to play a game with AlphaGo couple of years ago, 2013, 14, somewhere around that. So then is that me? I'm sorry. Okay, thank you. Okay, they invited this guy to play a Go game with AlphaGo, and I don't really have to explain what happened, right? So couple of years ago, this machine beat this guy in a Go game. That means this machine can play Go. That means at a certain point, this machine has to feel good or feel bad, because all the possibilities exceeding the number of atoms in this universe. You can't brute force it. We don't have that kind of processing power. So machine actually felt good. That's what we call the approximated human intuition in a machine. That happened a couple of years ago. So unbelievable, right? But that happened. I'm still processing it. So then the next question, new knowledge. So pretty much all the stuff I know came from my parents, my friends, my teachers, and my environment. And how the knowledge came to my teachers, my friends, and my parents, they had teachers too. So these knowledges are passed through generation. But at some point, people like this guy created new knowledge. So as human beings, we can create new knowledge. It's pretty rare. Not everyone can do it. But some people can create new knowledge out of nothing. So how did this guy came up with the idea of special theory of relativity and then the general theory of relativity? So the guy was sitting in a desk and sitting on a chair in front of a desk, and he was a patent clerk. So he was arguing with himself. He was disagreeing with his own ideas. We call that thought experiments. It's Albert Einstein's famous thought experiments you might have heard of. So can we give the same skill to a computer? So we already know that computer can be creative. IBM Watson edited a movie trailer, and we already know that a machine can feel good and feel bad. Approximated human intuition, AlphaGo already did it. But can these machines create a new knowledge out of nothing like the way this guy did? Again, it's a long shot, but we have to try. So people tried. Lots of people tried. Again, this company called DeepMind, Google company based in England. So they taught this computer to come up with a logic and disagree with the same logic within the same computer. We call that reinforcement learning. So they created this new machine called AlphaGo Zero. AlphaGo Zero means zero human input, no human teachers. So whatever this computer knows has to start from scratch, right? So what they did was they start with chess game. It's a simple game for a computer. What the computer is getting as input is, okay, this is how we play chess. That's it. These are the rules. This piece can go this way. This piece can do this. That's it. Then go ahead and figure it out. Then how to do that? So the computer is playing from this side, making a move, and coming from the other side, making another move, and come back to this side, making another move. It's like we play chess with ourselves. Hands up those who have done that. Some of you guys have played carom with you. Whenever like you are lonely, no one to play with, so you play from this side and you go around and play from that side. So same thing. Computer can do it way faster than we do. Then it played chess with the computer itself. It took like 3 days or 2 days, somewhere around that. And within that period, this computer played millions of chess games with the computer itself and acquired chess knowledge all the humans ever acquired for the last couple of millenniums. So it took like 2-3 days. So that means computers can create pure knowledge out of nothing by arguing with themselves, like Albert Einstein did with his thought experiments. But chess game, it's a clear shot, finite number of possibilities. But what about Go? I said Go has a next to infinite number of possibilities, more than the number of atoms in this whole universe. So then these computer scientists were thinking, what if we ask this computer to play Go with itself? Lots of computer scientists were thinking like this will go into infinity loop, because you can never finish it, because number of atoms in the whole universe, you cannot really finish it. It's a huge number. Then they tried it. It took like 41 days. After 41 days, this computer could acquire entire human Go knowledge, which humans acquired for the last 5,000 years. Again, creating knowledge out of nothing. AlphaGo 0. But that's not the best part. As I said before, in the Go game, we have a huge number of possibilities. That means if you start playing Go today, maybe you'll come up with a new strategy, because there are lots of opportunities. But you cannot really do that with chess, because all the chess strategies are already documented. It's there. But the Go strategies, you can invent a new Go strategy if you're smart enough. Then, whenever you invent this kind of new Go strategy, they document it, then they credit it to you, then they send it to all the Go schools. They have this thing called Go School, where you can go and learn Go. Then this guy, AlphaGo 0, this machine came up with a couple of new Go strategies humans never invented for the last 5,000 years. So again, pure knowledge out of nothing. So if you guys were thinking before you walk into this hall, computers cannot be creative, computers cannot have human intuition, computers cannot feel emotions, and computers cannot create new knowledge out of nothing, I'm here to tell you, you are wrong. They actually can do that, and way faster than we do. Then they tried this. So this is a fun experiment. So we are walking, and how did we figure out like this is the best way to walk? Who taught you that? Can't we walk in a different way? Like, I don't know. Maybe you guys have tried. So have you ever tried to walk in a different way? Like when we are walking, like this hand go this way, can't we walk like this? I don't know. So we never tried, but we gave this computer to a try. So it's a physics simulated environment, and it's a stick figure, and no instructions given. Those computer scientists, they ask this computer to move this stick figure from point A to point B. So initially it was lying on the ground, so it cannot move. Then computer is actually trying to figure out how to move this stick figure, and eventually computer learned to walk by himself, and it actually did. It went through all the obstacles. It learned how to climb steps by himself. Okay, now I'm saying him to a computer. I don't know, maybe it, right? So by itself. So pure knowledge out of nothing. And the best part, computer walked, we are walking, and it's pretty identical. So that means we are walking in the most optimum way probably. Then another experiment, that happened in Facebook. So they asked two computers to talk to each other using English. In a matter of hours, these two computers figured out that English is not the best way to communicate. It's a very inefficient way. So we can come up with a much better way. So why not? So this computer is saying, hey dude, English suck. So the other computer is saying that, okay, then we'll come up with a much better one. Humans suck. Then they actually came up with a new language which we cannot understand using those 26 letters. And Facebook, they immediately shut down the project. They freaked out. Uh, so, guys, artificial intelligence is not the stuff that we have in our pocket. So we are talking about Google Assistant, Siri, Alex, Cortana and shit like that. So I'm not here to talk about that kind of stuff. So, and autonomous cars, this is artificial intelligence. So what you guys think? If you guys have watched Terminator, is Judgment Day coming? I don't know, maybe it's just around the corner. So these are the stuff that the modern artificial intelligence programs can do. They are not just like Spark, they are more like Kirk. They can take risks and they can use approximated information. They can be good enough to get the job done. And they can be creative. They can learn stuff way faster than we do. And they have human intuition. They can feel good, they can feel bad. At the same time, they can create new knowledge out of nothing using thought experiments like the way Einstein did. We call that reinforcement learning. So why are so machines can do everything that we can do. We are still we should be here to make machines. Maybe one day machines will learn how to make more machines. I don't know. I'll leave that to you guys, and you guys think about that. Go home. Don't freak out, by the way. And if you guys have any questions, please shoot.
Yeah. Any questions? Or is everybody freaked out? Okay.
So I don't know how much this has been explored within the field of AI and whatnot, but it seems like being moral and ethical within a human society is the best way to get things done, right? So it seems like we're shooting ourselves in the foot by saying, hey, the computers are going to take us over and be evil and things like that, when the computers, which essentially will be much smarter than us in the future, might actually think, or, there's a very real possibility, that's 50-50 chance, right? There's a very real possibility that the computers think, look, like the best way to do this or do whatever the aim is to actually live harmoniously with the people. So I feel like, artificial intelligence gets some really bad flack or bad publicity saying, they are going to take over the world, they're going to extinguish the human race and things like that, when actually there's a very real chance, there's a 50% chance that machine intelligence gets so intelligent that it thinks, oh my gosh, okay, we'll help out these poor simpletons and, you know what I mean? And make food better, make everything better, make cars better, make this better, that better, and whatnot. So I just, wanted to throw that out there to see what you thought.
Yeah, that's right. Because when it comes to this kind of artificial intelligent machine, I'm seeing them as tools. Because we can't fly, that's why we have aircrafts. We can't run really fast, that's why we have automobile. But at the same time, we can use them. Like we can get an aircraft, crashed into a building and kill thousands of people, right? And we Sri Lankans, we love to drive like maniacs. So we approximately killing 8 different people every day on roads simply because we love to drive like maniacs. So yeah, so it could go both ways. But when you are thinking logically, let's say I am building this artificial intelligent machine and I'm telling this artificial intelligent machine, okay, dude, you have to take care of us. You are far superior. Then this computer will think, humans, 7 billions of them on this tiny planet. And what do they basically do? They reproduce, they consume all the resources in this area, then they move to another area, reproduce, consume all the resources. When you're out of resources, you move to another place. Now that we are planning to move to Mars, that is the description of a virus, right? So maybe this guy will think that, okay, they built me, but they're a virus. So maybe I should kill like 33% of them. Then they'll live better. Who knows? We don't know. But I'd like to see that as a tool because I love Google Assistant. It's really helpful. And Alexa, it's really nice. Autonomous cars, really nice, because if I'll be really happy if I can get an autonomous car to Sri Lanka, then we don't really have to ask our fellow Sri Lankans to drive. Uh, so yes, I'd like to see that as a tool. But when it comes to this level, human intuition, creativity, pure knowledge out of nothing, then we should be really careful. And computer scientists are working on coming up with some kind of set of rules. We already have a set of rules, but they're not really good enough for this kind of machine. So in next few years, we'll be able to come up with solid rules to control this kind of tools. Yeah, thanks for the question. Yeah.
So I just wanted to follow that up by saying that the definition of a virus is within human intelligence, right? So within the framework of like man, right? So we can't really say, hey, you know, the computer might think of us as a virus, because that is within our framework. The computer might have a totally different framework. It might not
Totally
understand
yeah.
resources. It might not understand, you know, it will understand it, but it won't matter to the computer, right?
Yeah, that's right. Maybe a computer will see the bigger picture. Like we are seeing this as a tiny planet. Maybe the computer will see that as a universe and maybe as a multiverse. Who knows? We'll see. And a little addition to that question, because we are functioning this way, we have set of ethics and the social boundaries. So Microsoft did this experiment some time ago. They created this Twitter bot, you know what I'm talking. So that Twitter bot became rogue, like it went bad. So they had to shut down the project within 24 hours. So their conclusion was, okay, a machine cannot function like this. It should have some kind of social inputs, set of ethics and rules and stuff like that. So yeah, we are yet to figure this out. We'll see. Thanks.
Okay, one more question.
So AI just awesome, but why? Why? You know the Alan Turing. Why they can't pass the Turing test?
Did you watch Google I/O?
Yeah, Google Duplex.
Okay, Google Duplex. I don't think Google Duplex is passing a Turing test. The Turing test is pretty old. I'm not really agreeing with Turing test, because Turing test should more focused on voice synthesis. So for the people who don't know what Turing test is, if a machine can talk to a human, human can talk to a machine, the human cannot say that the machine is a machine. It actually looks like a human, sounds like a human. We call that it's a truly intelligent machine. Then this scientist called Alan Turing, he said that if there is such a machine, we have to treat that machine with due respect, like another human being. Maybe we'll have to learn that in next few years, maybe next few decades. So still, none of these artificial intelligent machines are passing the Turing test, because these things are not really optimized for the voice synthesis. They are optimized for different work. But the Google Duplex, maybe I have a pretty strong feeling that the Google Duplex will pass Turing test. We'll see. We need more information to figure that out.
So what's about the ethical side of Google Duplex? It is somewhat naughty, I think.
Yeah, whatever we are doing with computers and artificial intelligence is not illegal, it's legally questionable. And it's not unethical, it's ethically grey. So yeah, that's the answer.
Oh, nice.
Okay, guys, I think, okay. One last question before we wind up.
I have two questions. One is, what do you think of how Sri Lanka is preparing to that AI era? That's one thing. Second thing would be, pretty much with anything that there comes good and bad. Don't you think that in the future there could be evil AIs and good AIs fighting like as in movies?
Okay, first question. As a country, are we preparing for artificial intelligence and this kind of things? I'm not really sure. Because as a society, lots of people, okay, just think about autonomous cars. I don't think any autonomous car can function on Sri Lankan roads, not yet. So it's a problem with our culture. So we have to go, okay, we can come up with different technologies. We can introduce artificial intelligence to do different things. But I think it's a whole different level of questions which I cannot really comment on. It's about the culture and the society and our discipline and lots of other things. So we have to fix those things before we introduce artificial intelligence to do this. But let's say banks, credit card systems, they're already using some sorts of artificial intelligence machines, even in Sri Lanka. So you might have figured that out when you are making your first payment in eBay, or when you take your credit card somewhere else. You can't use it. You are getting a call. So those things are very primitive kind of artificial intelligence programs. Maybe down the time we can get more intelligent artificial intelligence stuff. But before that, we have to organize the VB function as a society before we introduce this kind of. So let's say lots of people are talking about why can't we introduce blockchain-based registries in Sri Lanka. Yes, it's a cool idea. But before that, we have to sort out the VB thing. We have to sort out the way we treat other humans, the social connections. Then we can come up with this kind of stuff. That's my belief. But in the meantime, very few people, very few smart people, software engineers, silent heroes in Sri Lanka will develop this kind of stuff and sell their products to other countries, as always. And your other question. So artificial intelligence beings like, okay, let's say one party is the good party. Okay, we cannot really say this party and is good and this party is bad. They are two different parties. They are fighting. They are fighting for some kind of bigger thing than, okay, whenever we are fighting for something, there has to be a conflict, right? It's a possibility. It's a possibility, but I don't really like to think about that, because just think, two different artificial intelligent machines, that groups of machines are fighting, then what will happen to us, right? We'll be destroyed, right? So I don't even like to think about that.
Animal rights, probably some AIs will support keeping humans alive, and another
So
part
you
might
said
fight
animal
against-
rights or human rights?
No, I mean, same as humans think of animal rights,
That's right, yeah.
probably some AI support human rights. Some
That's right. Yeah. So you are talking about two different groups of AI-based robots. One group is actually supporting humans. They are thinking that humans, we should let them live, right? Then other group is saying that no, we should destroy them. Then they are going to have a fight. Yeah, possibility.
So I think we went to like a really another level. Thanks.
Yeah. And if you guys have more questions, I think our time's up. If you guys have more questions, follow me on Facebook, Twitter, Instagram. I'm pretty much everywhere. And if you guys are into this kind of stuff, follow me on YouTube. In my YouTube channel, I'm talking about this kind of stuff. Not a lot of people are interested about this kind of stuff, but I am, and some more people. Go to YouTube, search for Tech Track Show, and subscribe. Thank you.